If your network were a city, would you rather memorize every street or understand why the streets were built, how traffic flows, and what rules keep it all moving? Today we're diving into a CCNA enterprise path that says, start with the blueprint, not just the toolbox.
Exactly. The idea is to train you to think like an engineer. With automation and AI getting better at pushing configs, the differentiator is knowing why a technology exists, how it behaves under the hood, and only then what to type. That shift is huge for CCNA candidates, and even bigger for real-world jobs.
Let's unpack that framework. Why, how, what? It sounds simple, but it's actually a study habit makeover. Can you walk through it with a routing example?
Take OSPF, the why. Distance vector protocols like RIP pass around routes with minimal detail and can struggle in larger dynamic networks. Slow convergence, limited visibility, and potential for loops. Link state protocols, like OSPF, share a detailed map of the network's topology, which scales better and reacts faster to change. That's the problem it was introduced to solve.
So the how is the interesting plumbing. What's happening behind the scenes when OSPF builds that map?
Routers exchange link state advertisements to describe their neighbors and costs. Each builds a link state database, the network's atlas, and then runs Dijkstra's algorithm to compute shortest paths. They form neighbor adjacencies, synchronize their view of the world, and keep it updated. When a link fails, the recalculation is targeted and fast. It's like a GPS that watches road closures in real time, not a rumor mill that hears, maybe the highway's closed.
And the what brings us to the keyboard. Configuring OSPF, confirming adjacencies, checking that new routes show up where they should. But this learning path doesn't stop at routing, right?
Not at all. It starts with fundamentals, how routers and switches think, how IP addressing actually drives communication, why VLANs and trunks segment traffic, and moves toward enterprise topics like dynamic routing, securing access with ACLs, translating addresses with NAT, and the basics of automation. Each topic is a stack of short lessons, hands-on labs, and quizzes, so you're constantly applying and testing what you learned.
I like that it's not learn Command X for problem Y. It's understand the system, then choose the right command. That's the difference between passing an exam and walking into a real network without panicking.
Absolutely. For example, in OSPF, you'll explore design choices, areas to contain failure and reduce overhead, route summarization to simplify the map, and filtering to keep the right routes in the right places. On the switching side, you'll see how redundancy is a friend until it creates loops, and how protocols prevent those loops while still giving you resilience. It's engineering trade-offs 101.
Let's talk distance vector for a second. When does a simpler approach still make sense?
In small, stable networks, a distance vector protocol can be enough. It's straightforward, low overhead, and easy to grasp. But as soon as your topology grows, or your change rate increases, you want the richer visibility of link state. And knowing that difference helps you explain to a manager why the easier choice isn't always the right one.
The automation promise is alluring. Let scripts and platforms spin up configs, but it can also hide mistakes. How does the path coach people to use automation intelligently?
It grounds you in the fundamentals first, then introduces automation and controller-based ideas as accelerators, not substitutes for understanding. You practice verifying, interpreting outputs, and spotting patterns. Automation becomes a power tool you wield with judgment. Template the design you understand, then validate what the system pushed.
There's also a confidence piece. Labs and quizzes aren't just busy work. They build that diagnostic muscle memory. You start recognizing symptoms. Odd IP addressing, missing VLANs, stale routes, misaligned default gateways. The first time you fix something quickly, it's addictive.
And because each section stacks logically, you see how everything interacts. Addressing decisions affect routing. Segmentation affects security. Redundancy affects convergence. The goal isn't trivia, it's a mental model that makes the exam feel like a snapshot of your daily reasoning.
I'll throw in a learning tip. Narrate the packet's journey. It enters this interface, gets tagged by that VLAN, hits this ACL, routes via that protocol, and returns through this NAT. If you can tell that story, you can troubleshoot it.
I love that. Packets are commuters, protocols are traffic laws, and configurations are the road signs. When the commute breaks, you don't guess, you trace it. That's the mindset this path cultivates.
Before we land, what's the biggest mindset shift you want listeners to adopt?
Stop equating knowing commands with knowing networks. Commands are an expression of design. If you start with why the technology exists and how it behaves, the what becomes obvious, and the results become repeatable.
So, begin with fundamentals. Embrace the why, how, what. Practice until verification feels natural, and let automation amplify, not replace, your understanding. That's how you prep for the CCNA and for Monday morning at a real job.
And here's a final question to take with you. In a future where AI can configure almost anything, what uniquely human judgment will keep your network reliable, secure, and elegant? Learn that, and you'll be relevant for a long time.
Thanks for listening. Go build the mental map, not just the muscle memory, and we'll see you on the next journey.